Okay, great. So, hello everyone. Welcome to Lab 11. Today, we will be learning about the ratio, the root test, and the power series. Okay. So, in the previous lab 10, we learned about the comparison test, and we also applied few tests for a bunch of problems, right? And it was too lengthy. So remember, for lab 10, it's due tonight. So make sure you submit on time. Now here in lab 11, we will be applying, you also have, in total, you have 16 problems. You can take a look at your lab manual if you want to. So you have 16 problems for lab 11, and you have to apply either the ratio or the root test, okay? Do not include any other test. You have to apply only these two. Fine. So let's get started with that. Now, before that, let me tell you what is alternating series. I mean, you all know what it is, but let me revise you on that. Now, suppose that we have an series AN, okay, such that it has to follow this format. That means you must have -1 to the power of n, because this is alternating series, right? And do not worry about Bn, it can be anything. Now, when we say this alternating is converging, that means it has to satisfy three conditions. One is that the Bn, that sequence has to be positive. It is greater than 0, so it has to be positive. The second condition is when n tending to infinity, it has to give you the limit equal to 0. Not any other number, but it has to be equal to 0. And in addition to that, Bn has to be a decreasing function. Okay, then only we can say summation An converges. So you have an alternating series in this format. You need to prove that Bn is converging. Then only you can say An also converges. Okay, and that's about alternating series. Now, ratio test. Let me zoom it. Ratio test. Suppose we take the same sequence, series AN, and you need to find the limit L. How? You need to apply limit n tending to infinity for the sequence AN plus 1, and you have to divide that sequence or series by AN. Okay? Use this formula to find L, and if that L is less than 1, we say it is convergent. If not, it is divergent. Okay, and we have a special case where L equal to 1. You might see this quite often. Okay, so if you get L equal to 1, that means it could be divergent, it could be conditionally convergent, or absolutely convergent. Okay, you may see all these conditions. Now, when you have this case, then you need to follow the root test. Okay, to find out whether this is divergent or convergent. After applying the ratio test, you also have to apply the root test if you get L equal to 1. Okay, and what is root test? How can you apply that? Suppose you have a sequence AN again, then you need to use this formula to find the limit EL, and you can follow the same condition given here. Okay, so that's how you can find out whether it is convergent or divergent. Got it? Now you can use this or even here, this one. It doesn't make a difference, both are same. Even if you write a square root of 3 or if you write square root of 3. In this way, both are same, right? Now, for an example, let's take n 1 over n equal to 1. Okay. Now, 1 over n is equal to, when n tends to infinity, 1 over n is equal to 1 over infinity, and that gives you 0, right? 1 over infinity is 0. Now, if you plug in this 0 here, that gives you n to the power of 0, which is equal to 1. Anything to the power of 0 is 1. So that's your, that's about your root test. Now, last topic is the power series. Now, in a power series, it has to follow this format. Now, what is the difference between a power series and the series which we saw just now? That is, for example, this one. Now, what do you think is the difference between these two? Now, tell me, what is the difference between this one and this format? Any guess? No, the limit is not the answer, because here n is also tending to infinity and here we have infinity. There's one thing that is not there, common in both of the terms. Apart from Cn and A, apart from those two, what do you see? Exactly, the x. Now, it is quite important because you have to find what is n. Also, you need to find what is x. You have two things to find out, and it is a function of x. The series, which is a function of x, which could be written in this format, we call this as power series. Okay. Now, the difference is, till now, you have solved series that are in terms of n only, right? You were applying the limit and tending to infinity. You used to find out the number EL. That was quite easy. Now, what if I have x into n to the power of 1 over n here? Then you will get x here, right? You will not get an exact number. Then it is very hard to find out whether it is less than 1 or greater than 1 or equal to 1. So we will see how to solve this power series as well. Okay. Now, more information about this. Now, how do we say that this series is converging? If the x limit is between a minus r and a plus r. So a is a number which is already given in the problem. Okay. R means the radius. Got it? So this r you need to find out. So if the x is between these two limits, then we say it is converging. If not, we will say diverging. Now, how to find this r? You can do this by applying the ratio test to the series, power series. Okay, so we will do a couple of problems. Let me see if I have some sheets here. let us start with problem 1. So as I said you in this lab, you have two things. You have two types of things. That is, in the first type, you need to apply either the ratio test or the root test. Okay. And then in the second type, if you look at your lab manual, in the second type, you will have to apply the ratio test to the power series. And the question is, what is the value for the radius r? And you also need to find out the interval of convergence, these two. Okay, that's in your second type. So we will cover all those examples in today's lab. So let me start with summation n equal to infinity. So 1 to infinity, 1 over n factorial over n factorial, and we will try to apply the ratio test in order to find its convergence. But if L is equal to 1, then apply the root test. Okay, so we will check what is the limit L. If it is equal to 1, then we need to apply root test for the same problem. Okay, so let us start. We know that an is equal to 1 by n factorial. It is given in the problem. Now, what is the formula for ratio test? That is limit n tending to infinity, absolute an plus 1 divided by an equal to absolute of. Now, when I say an plus 1, that means you are just replacing the n with n plus 1, right? So 1 divided by n plus 1, the whole factorial multiplied with an. Since an is in the denominator, if you cross multiply that, then that becomes a reciprocal. And somebody tell me what will be the result when you multiply these two. One and one, they get cancelled. Then all you have left out with n factorial divided by n plus 1, the whole factorial. But I want you to simplify that one. What do you think you will get if you simplify n factorial by n plus 1, the whole factorial? I will give you a hint. Now, n factorial, I will write that as it is. Not good at these devices. Okay, so n plus 1 can be written as n factorial into n plus 1, right? How? Now, how do you expand 2 factorial? It is 2 cross 1, right? Now, how do you expand 3 factorial? It is 3 cross 2 cross 1. is -1 the whole factorial, and n factorial. We also have some numbers here. Has to be n-1 the whole factorial. Okay, now what if this is n+1 the whole factorial? Then this is n+1 into, yeah. Understood? Or do you want me to explain it in another way? I hope you have understood. So use the same thing here. Okay, so n+1 the whole factorial can also be written as n+1 multiplied with n factorial. Now you can easily divide the numerator and denominator, cancel out those two things, and whatever is left out is limit n tending to infinity en+1 divided by an will be equal to 1 divided by n+1. Okay, oops, I forgot to write the limit n tending to infinity. Now what happens for this series when limit n is tending to infinity? What do you think will be the answer? Exactly, very good. So 1 over infinity is what you get, then 1 over infinity is 0. So according to ratio test, what was the ratio test here? According to ratio test, if you get limit L less than 1, it is convergent. So now tell me whether this series is converging or diverging. Very good. So we got L equal to 0 and it is definitely less than 1. So according to ratio test definition, the series is converging. Is convergent. So there is no need for you to apply root test for this problem. I will give you a few minutes to take it down. I hope you can clearly see my writing. Hope you have taken down. Problem. You have n equal to 1 to infinity 2 over n divided by 7 to the power of n. Now let us apply root test for the same problem. Let us apply root test for the same problem. Now we get an equal to 2 by 7 to the power of n. So we can also write in this way. Right? So the formula is L equal to limit n tending to infinity nth root of the sequence, the series an. Right? Now I can also write in this way, n tending to infinity 2 by 7 to the power of n whole to the power of 1 over n. Right? Nth root can also be written as 1 over n. Now what will be the final answer? You get 2 over 7. How? This n and this n will be cancelled. Okay, and the only number that is left out is 2 by 7. Now, can you tell me whether this series is convergent, divergent? You get L equal to 2 by 7, and you need to decide whether this series is converging or diverging. How do you do that? Check the definition for the root test and see what happens when L is less than 1. Because L equal to 2 by 7, that is less than 1, right? If you solve this in the calculator, you get maybe 0 point something. So it is clearly less than 1. So if L is less than 1, we say the series is convergent. Okay, and that's for second type. I have one more example to complete. That's the last one for the second type. We will solve the power series using the ratio test. Let us start with example number 3. Okay. We'll take summation n equal to 1 to infinity x plus 7 to the power of n into n square. Okay, so clearly our an is the same given series. I don't know why I say sequence all the time. So this is n square. Now let us apply the root ratio test. Limit n tending to infinity, an plus 1 divided by an equal to limit n tending to infinity, n plus 1 is x plus 7 to the power of n plus 1 into n plus 1 the whole square divided by the given sequence. Let us first simplify the x term and then we will go to the n term, okay, one by one. So limit n tending to infinity is 7. For example, if you have 2 to the power of n plus 1, we can write it as 2 to the power of n and 2 to the power of 1, right? So we will use the same formula here, x plus 7 to the power of n and multiplied with the same base. So here we get n plus 1 the whole square divided by x plus 7 to the power of n, okay, into n square. So you can clearly cancel out these two. It's the same thing. Now let us rewrite the above equation n tending to infinity. And I will write x plus 7 here and here. I can take out n plus 1 the whole square divided by n square outside. Why? Equal to 1 to infinity is a positive value always. For any number of n, in this limit, n is always positive and we do not have to use the absolute sign for a positive number. Okay, so and that's the reason I'm taking it outside the absolute sign, and we have n plus 1 the whole square. That is a plus b the whole square formula, right? So we use a square plus b square plus 2n divided by n square. Just expanding the term. Now we get limit n tending to infinity, x plus 7. We can take n square common from the numerator. So I will get 1 plus 1 by n square plus 2 by n divided by n square. Okay, now these two get cancelled out and this tends to 0 as n tending to infinity. This as well goes to 0. So we get x plus 7 into 1 and that will give you x plus 7. Okay, now the problem is you need to find the radius r and also the values for x. Okay, now we want this series to be convergent. So according to ratio test, when this L is less than 1, we say the series is convergent, right? So we take x plus 7 is less than 1. Now, if you remove the absolute sign, that means you are evaluating the same thing between opposite sign values. Okay, now I need to find the value for Find the value for x. So how can I do that? At first, I have to remove the 7 number here. That means I need to subtract 7 on both the side. 1 minus 7 and minus 1 minus 7. Okay, so here I get negative 8 less than x less than negative 6. That means this is the interval. The point is the series converges. Then what is the value of r? You take the formula for the power series. The a here is already given in a problem. So in our problem, it is x plus 7, right? That's the problem we had. So a equal to 7, then r has to be a is 7. What is r? A is equal to 7 in this interval, then r has to be equal to 1, right? Irrespective of the sign, the number, the radius is always positive. So r equal to 1. And what is the interval of convergence? Interval of convergence will be equal to negative 8 and negative 6. That's how you need to find out the radius and the interval. So the power series problem could be quite lengthy, but rest of them are short and easy to do. Okay, so this will complete lab 11. We have till lab 13. So I'm not sure whether your lecture instructor wants me to complete lab 13. So let us wait for their decision. But lab 12 is definitely there. So we will be meeting next week, and I will let you know the last lab. Okay. So this is it for today. If you have any questions, you can stay on the Zoom. If not, we can meet next week.